Okay, so we're gonna try this recording. See how it goes. It says we got like 42 minutes to go on this, so you can see here that we got the new system set up. I cut this piece out and welded it up so we have a bigger piece of steel sticking up so that the whole system could be lower. And the point of this is that if you take a look at the measurement here, I don't know if we can get this on here, but you can see by according to this that we have almost try to get it in the shade there, like 15 millimeters of thread. Now that's threaded in there a couple of times, so that means that when I crank it all the way down and tighten it down, that we got a really good bite holding this head on, right? So I'll just crank it down. I'll switch that. We'll crank it down, get it good and tight, because before there wasn't enough threads, you know. So because with the original setup that we had on it, there wasn't enough threads holding it down. Yeah, it's pretty decent. That's pretty good. They're all pretty good now. That's got it cranked down pretty good. I target to about, I'd say that's 30 foot-pounds I was doing that. And then now you can see that this piece of steel welded to this one, bolted. This bolt here were just put on here to hold the whole system together when I welded it. And then this is welded to that, and that's welded to that. So basically what we did was cut out the middle section and then put this secondary piece on top. It should work out pretty good. I drilled a hole through here, is like 3/8, and then just welded right through. So we got, it's kind of like a welded rivet at that structure point. So at least we have some kind of structure there, as well as the inside. It's been welded all the way across, so should be strong enough. And the thing I like about this is that, I mean, before the head of the bolts was coming up to here, where my fingernail is, and that wouldn't have been enough threads. Like, if this darn thing works, it needs to be strong and hold together. Hello. So it is October the 9th, 2018. We're going to do a test run on the device. I had to install a spring in here to make sure we had a pretty good a connection for our RCF extraction, and it looks like it's tracking pretty decent. I did give it a quick little test to see if it was doing anything, but no results yet. We'll start it up and see how it goes here. So we got 12 volts coming out of here, which go into our motor here. It's running about 15 amps. This little drive motor here spins the unit, and then of course we got the RCF, obviously, because it's spinning, and we got it. The permanent magnets, so we got a magnetic field, and we should be able to extract the RCF that's coming outside the coils and dump it through this cable here. Let's sneak underneath here. Plug this, and then this comes out over here and ties into our dump coils. And you know what? No, this goes to the RCF coils. There's our dump coil over here. So the dump coil is then switched to I got that hooked up to. I got that hooked up to 5 volts. So the 5 volts then goes through here and is switched to this unit, so that on the power stroke, which should push the RCF off of the RCF coils. But that doesn't seem to be happening. So I might have a polarity issue, but let me get back with you on this and see if anything else is winding up. It doesn't look like it. So you can see here that we got our RCF coil here is our 18, which comes up to here. So what I'll do then is I'll reverse the polarity on this, and our head should definitely be strong enough to hold in case it does run. And then this is our white brown one here is for our power. I had these marked 3.3 volts and 5.5, so I got this one set up for 5. Get high up here. Should be good to have a little more room to work on it, but That'll be all right. We'll figure it out as we go. First thing I'll do is I'll just check to see if there's any voltage here at all, and then we'll change the polarity of the RCF, and then after that we'll change the direction of this. We'll spin it the other way, because it doesn't really matter which way it goes as long as we get the result that we're looking for, right? And by changing the direction of this, it's going to change the polarity of the diodes without me having to actually resolder all the diodes on there. So that should still work out pretty good. We'll try those tests and go from there. So here you can see that I cut the line coming in here, and I'm just going to go a direct feed with no load to get a voltage on that. Turn it on. You see that we're showing about 2.3 volts. I just got the polarity backwards, that's all. But that's why it's showing a negative, right? But the fact is that we are producing something. So I'm just gonna hook up the leads here for the ohms on the RCF coil. So there you can see it's 10.2. So that's pretty darn close, because the coils are about 40 and we got 4 of them in parallel. So that should be pretty good. We know this is working because we got 2 volts coming out of it. And I did actually have my RCF coils backwards with the dump coil. So I'm going to redo it. We're going to set it up as 5 volts for now. But I'm thinking we're going to have to bump it up to 12 volts. Because when I went across the dump coil, the RCF is 10 and the dump coil is about 14. So that's 14, we put 12 volts on it, that's 1 amp. It should be able to handle an amp. It's 24 gauge wire. So I think I'm going to upgrade that to 12 volts right now while we're doing this little change around. And who knows, maybe this thing's going to be up and running before too long. I rewired it so that the motor was going to run in an opposite direction, and tied everything to positives so that they're relatively connected with the same polarity, even though they're isolated circuits. And I think we burned out our power supply, but oh well. It was only like $5 for this power supply. It's a computer power supply, and then of course I just, tie all the 12 volts together and then run it off of there. But the odd thing that I find, because when we were spinning it clockwise, we were getting 2.25 volts on the slip rings. That's with a load on it. And then when I was rotating it the other way before the power supply burned out, we were getting 1.9. So I'll have to think about that. But it didn't work. I didn't get the results that I was looking for. So I'm not sure what to do at this point. I will take a break now, grab something to eat, and pray about it and see what the good Lord wants me to build next. Sure, it's fun to build this device anyways. So anyways, that's it for October the 9th, 2018. Bye-bye. As you can see, I just took a look at the fuse, and you can tell that we blew it, So it was only a 15 amp fuse. It's probably drawing like 18 or 19 amps. So I'll just hardwire it through, and we'll turn it up here just to show you it's running backwards, and then go from there. Okay, so I disconnected the pulley that was up here, and I put on a bigger one, but the motor is taking too much power. I only got like 18 amps coming out of my power supply, and it could barely drive it. So I put the original pulley back on there, the smaller one, and then of course I changed out these diodes, the polarity of these diodes, and I grabbed these diodes out of my package that I had there. I had a whole bunch of diodes, and I just did a voltage test on this, and it jumped from 1.9 volts all the way up to 13. So I didn't expect that. I'm going to turn it on here again, and we'll see if we can get those voltages to show up. This is turned on. I'll just set this down. To get the polarity right, that's 13.5. So you can definitely see that going with a different type of diode. We got voltage like, oh my goodness, which is pretty darn good. That's like 6 times better than what it was before. 6.5 times better, right? Let's disconnect this here. I'll shut that off. It's a good power supply because I can get like 30 amps, 12 volts, and 5.5 volts and 3.3 volts. So it's pretty good. Or I think it's just 5 volts is what it is. But anyways, aside from that, at least now we got some voltages that we can say are a lot better than before, and that's coming out of the RCF side. So what I'm going to do then is I'm going to reverse the drive motor, and then we're going to see what the voltage does going the other way, and should be interesting because the generator is now see that if the diodes on this side here are the negative and the RCF is coming out here, this diode could act as a filter, and of course natural gravity is always stripping away RCF, so the RCF might not go past the diode, right? But if I put the diode on the other side, so that now the non-semiconductor side has the RCF coming out, then we take that signal, we run it into the engine. When it comes back again, if we don't use it all up or dump it all into the engine, it'll hit the diode and dissipate. At least that's the theory. So what I'm going to do is I'll change the power feed for the drive motor, and then we'll test again to see what voltage we get. I'm curious to see if it's going to go higher or lower. So if it should go, it maybe go like 0.3 of a volt or at most 0.7 of a volt difference. But it's curious to see because I didn't expect that. I didn't expect 13 volts coming out of it. That's awesome. Anyways, till later. Okay, so we're going to try this again. This time I changed the polarity of our drive motor, and we're going to see what voltage comes out of it then. I'm expecting either 14 or 12.5. So let's get this fired up here and see. So I'm just going to hook this up. We'll take our probes again. Let's go like that. And we'll put the negative one like that. I don't want to get hung up here. That's backwards. I'm switching around. So we got now. It's 14. My test point is coming right out of here across these two slip rings, eh? That's what's going into our RCF coil. Let's shut this off. That's just what's going into our RCF coil. 13 volts, which isn't too bad because we got 10 ohms on it, so wow, that's pretty decent. I'll do some more tests and see what we figure out. We'll keep going with this.